Let's learn how to write chemical formulas for compounds that have polyatomic ions in them. So what's a polyatomic ion? Well, it's what happens when a bunch of atoms come together and they connect together and form a big clump. And that clump itself has a charge. So here's a list of some of my polyatomic ions, and it has stuff on it like nitrate, which is NO3 1-. And what that means is that one nitrogen atom forms a clump with 3 oxygen atoms, and that this whole thing, these 4 atoms together, have a charge of 1-. Or we've got stuff like ammonium here, which is NH4 1+, which means you have one nitrogen connected to 4 hydrogens in a big group, and that group of atoms together has a charge of 1+. Okay? So, here is the name of a compound, calcium nitrate. Let's go through the steps that we have to take to write the chemical formula for this compound. There are 2 things you're going to need for this. The first is a periodic table. I'm using this kind of weird version where I've left out a lot of the elements because I think they're distracting, but I've kept in the ones that are important for what we're doing. And then you'll need a list of polyatomic ions, okay? This is a short list of just my favorite polyatomic ions, and I bet that your teacher or textbook has a much longer list of polyatomic ions with a whole bunch of extras that they want you to learn, okay? If that's the case, it's no big deal, because if you learn how to write compounds with these polyatomic ions, you'll also be able to do it with whatever extra ions they want you to use. Okay, so anyway, ions. Since we're talking about polyatomic ions here, the compounds that we're going to be writing formulas for are all ionic compounds, which means that we're going to have to find out what the charges on both these things are in order to write the formula for it. Okay? So let's start out with calcium. What's the charge on calcium? Well, that's pretty easy. Calcium is right here on the periodic table, and it's in this column. Everything in this column has a 2+ charge. So I'm going to write this right up here, Ca 2+. Okay, now nitrate. Nitrate's a polyatomic ion, and so it's on this chart here, on this list. Nitrate, I'm sorry, that was nitrate. Nitrate here is NO3 1-. This whole group of atoms has a 1- charge. So now I ask myself, when I have one calcium atom and one clump of this nitrate, do the positive and negative charges balance? They don't, because I have 2+ from the calcium, but I only have 1- from the nitrate. So at this stage, I can add more of either one of these, or of both, until I get the charges to balance. Since I have 2+ here, and each one of these nitrates brings me 1-, I'm going to add another nitrate, NO3 1-, so that now I have 2- total, which will balance out my 2+ from calcium. Okay? So now I have the charges balanced. And now I want to write this in a chemical formula that shows how many of each I have to have in order to balance out the charges. So I need 1 calcium. So I'm going to write that as Ca without anything after it, and that means that I have 1 of them if you don't write anything after it. And then I want to say that I have 2 nitrates. So NO3, there's my nitrate. I want to say that I have 2 of this whole thing though, right? I want to multiply this whole thing, NO3, by 2. So what I'm going to do is I'm going to use parentheses. I surround the polyatomic ion with parentheses and then put down here how many of this whole thing I want. So it's going to be CaNO3 in parentheses 2. Means 1 atom of calcium and 2 whole clumps of nitrate. Let's do a couple more. Ammonium nitride. We got to bring our 2 tools back here, the periodic table and the list of polyatomic ions. Okay, so ammonium, you may recognize from this list. It's a polyatomic ion, and it's NH4 1+, a whole clump of atoms that has that 1+ charge. Now nitride. Nitride is right here on the periodic table. It's what we call nitrogen when it has a charge. It has a charge of 3-. Now don't get confused. Some people confuse nitride with nitrate and nitrite, which are polyatomic ions. And oftentimes people are like, well, how do you know which is the polyatomic ion? How do you not get confused with things that are on the periodic table? I'm sorry to say this, but the only good way to do this is to memorize them. People are always saying that it's a good idea to memorize the polyatomic ions so that when they pop out like ammonium, you know right away where to find that it's a polyatomic ion, and you don't have to waste time trying to find ammonium on the periodic table. It's not going to be on the periodic table because it's a polyatomic ion. Okay. Anyway, we got ammonium NH41+ and nitride, which is N3-. Now we got to balance the charges if they're not already balanced out. We have 1+ here and we have 3-. Since each of these has a 1+ charge, I'm going to add 2 more so that I have a total of 3+, 1, 2, 3, to balance out my 3- on the nitride. Okay? When I need more than one polyatomic ion, I surround it with these parentheses, and then I write the number afterwards. 1, 2, 3. That's how I show that I want 3 of the ammoniums, and then I only want 1 nitride because it has a charge of 3-. And so I can just write it like that without anything after it, and that means that I have 1 of them. Okay. Sodium carbonate. Back to the periodic table, back to the list. Okay. Sodium here is in my 1+ column. So I'm going to write Na1+. And carbonate is a polyatomic ion. Don't waste time trying to find carbonate on the periodic table. Just memorize this list and you'll know right away that it's a polyatomic. Carbonate is CO3, and this whole chunk of atoms together has a charge of 2-. Now I want to balance out the charges, 1+ versus 2-. So I add another one of the atoms that has a 2+. And now I'm going to write the chemical formula as Na2, to show that I have 2 of them, CO3. Now sometimes people think that you should surround the polyatomic ion with parentheses. No, no, no. You only do that if you're multiplying it by a number, like 2 or 3 or 4. But if you just want one of them, all I want is 1 carbonate, you don't use anything at all. No parentheses, no number 1 after this, just CO3, and that means that you just have one of these chunks of carbonate. Okay? We'll do 2 more. Ammonium phosphate. Back with the periodic table and with the polyatomic ions. Both of these turn out to be polyatomic ions, and again, you'll recognize it right away after you've memorized this. Ammonium is NH4 1+, and phosphate is PO4 3-. I want to get the charges to balance here, so I'm going to add 2 more ammoniums for a total of 1, 2, 3+ charge to balance out my 3- charge. So I've got ammonium NH4. I want 3 of those. It's a polyatomic ion, so it gets parentheses. Then there's a 3 after it to say I want 3 of them. And then I've got PO4 here, put it right after. Again, since I only want 1 of the phosphates, only 1 of the PO4s, no parentheses with 1 or anything. I just write PO4, and that's all I need to say that I have 1 of them. Okay, here's the last one. Magnesium phosphate. Periodic table, polyatomic ion list. I find the charges for magnesium and phosphate. Magnesium is here. It's Mg with a 2+. And phosphate, we just did this. It's right here. PO4 3-. So now I want to get the charges to balance, and this is one of the trickier ones because sometimes you got to do a little thinking before you can figure out how this is going to work. I'm going to add another phosphate here to get a total of 6-. And now I can add 2 more magnesiums to get a total of 6+. So I add another Mg, 2+, now I have 4+, and now 1 more, and I have 3 of them, a total of 6+. So I need 3 magnesiums and 2 phosphates for these charges to balance. And now I'll write this as Mg, 1, 2, 3, and PO4, I need 2 phosphates, so I've got to break out those parentheses, PO4, multiply that whole thing by 2, so I use a parentheses and put a 2 there. Okay, a few take-home messages. I know it's a pain. It's really helpful to memorize the list of polyatomic ions so you don't waste time looking for something like phosphate on the periodic table, or confusing phosphate with phosphide, which is P3-, very different than PO4 3-. So if you memorize the polyatomic ions, you won't make those mistakes. The other question that people often ask is they look at a list of the polyatomic ions and they're like, how am I supposed to know this? You know, if someone just said nitrate or nitrite and I knew that it was NO2 1-, is there a way that I could figure out what the charge would be without having to memorize this? Or, you know, could I figure out the charge on sulfate? Unfortunately, the answer is no. It's really, really hard to figure out what the charge on a clump of atoms would be if you haven't just gone through and memorized this. So as much as I always like to say don't memorize things, and I usually like to teach the rules behind how you can figure it out yourself instead of relying on memory, polyatomic ions are one of the few things that, yeah, like I hate doing it, but you just kind of have to, like, you know, grin and bear it and memorize these guys seriously. When you're writing lots and lots of these formulas, it's really going to pay off in the long run. So anyway, that's how we write chemical formulas for compounds that have polyatomic ions in them.